Good morning, student. This video is for those students who were unable to join my live classes given to you on Saturday, and we have started the second term syllabus, and the first chapter for the second term syllabus we are going to start, that is chapter number 4, simple machine. First we will discuss about what is machine. Let us define first machine, that what does machine says. We can say that machine is a device. We can say that machine is a device which makes our work easier. Machine is a device which makes our work easier. For example, we can say there are so many examples that makes our work easier, like we can say screwdriver. Screwdriver is a machine which makes our work easier. We cannot open any screw by our hand or cannot tighten any screw by our hand, but with the help of screwdriver we can do this task very easily. Then pliers, we cannot cut the wire, the thick wire, by our hand or by our teeth, but when we use plier it becomes very easy. Then washing machine. These are the types of machine which makes our work easier. In short, you can say machine is a device which makes our work easier, or you can say machine is a device in which human effort is reduced. Human effort is reduced to a large extent. Human effort is reduced. It means that by applying less force we can do lot of work. By applying less force we can do more amount of work. Now in this chapter we are going to study about simple machine and some types of simple machine. They are lever, wheel and axle, pulley, inclined plane, wedge and screw. One by one we will proceed to these topics. The first topic which we are going to study in this chapter is simple machine. This is the first topic which we are going to study, simple machine. As we all know that in our daily life we are using so many types of simple machine, like just now example I have given, screwdriver, pliers. These are the simple machines which we are using. Scissor, that makes our work very easier. As from the ancient times we all are using machines, because in the ancient times the people were unable to do the difficult task. That's why they have started using small machines. Those machines are called simple machine. Now as the time passes, those simple machine, according to the requirement of the human beings, those simple machine gets modified and now they are being presented in a good way. Like we can define simple machine as the machine which have very few parts. The machines which have very few parts. It means the machine which contain only 1, 2 or 3 parts are called simple machine. Machines. The same example like screwdriver. As you know that screwdriver, what does it contains? A handle which is of plastic or any other material, fiber material, and one rod in which tooths are there for opening nut and tightening the nut. It is made up of only two part machine, screwdriver. Plier, it is made up of iron rod and one pivoted, it is pivoted in the center. It is also a simple machine. There are two types of machine. One is simple machine and another one is complex machine. Complex means tidy, little bit tough, tedious you can say. Complex machine, the machine which are made up of machines which are made up of several simple machine. If a machine which is made up of several simple machine, that type of machine is called complex machine, like engine of car, washing machine. These are the complex machine. Now what you have to do, you have to read the books, then all the concept of this topics will be clear to you all. Now let us move to our next topic. Our next topic is function of machine. Our next topic is function of machines. What are the function of machine? There are four function of machine. First, machine act as a force multiplier. In your book this term is not given. I am teaching you this term in advance because you will see this term in class 10th. But the first point which is given in your book is represents the same term, that is force multiplier. Multiplier, it means it multiplies. Force multiplier, it means by applying less force, we can do more work. Let me give you one example. Suppose if we want to lift a heavy load which we cannot lift by our hand, how we can lift that load? By using machine, that is pulley. It means we are applying less force and we are doing more amount of work. That's why the very first function of machine is force multiplier. Second is changing the point of application of force. Changing the point of application of force. It means that if we are changing the point of application of force, we can do our work easily. Suppose let us take an example of cycle which is given in your book also. As cycle does his work on his wheel, but we are not applying force directly on the wheel, we are applying force on its pedal. It means that we have changed the point of application of force and this makes our task easier. Third one is changing the direction. Changing the direction of force. Direction of force applied. Changing the direction of force applied. If we are changing the direction of load and effort or force, if we are changing the direction of force, it makes our work easier. Like suppose this is a roof, and one boy is standing here and he has to lift water from downwards. How will he do? He will apply the force in upward direction, then only this bucket will be lifted upwards. If the same boy will use pulley, if the same person will use pulley to lift the same bucket, it means direction is being changed. The boy is applying force downward and the bucket is lifting upward. It means that we have changed the direction by using machine. So we can change the direction by using machine, and this results in effective and easy way of doing work. And the last is the fourth one, gain in speed. gain in speed. Now, if we are using machine, it gives us speed also. Like let us take an example of scissor. As I have given you same example, as this is a scissor, you can see that if we are cutting any cloth, we used to hold the handle of the scissor. This is the handle of the scissor and these are the blades of the scissor. As we are holding a scissor and trying to cut a piece of cloth, what we will see that the handle of the scissor moves little bit while the blade of the scissor moves a long distance, covers a long distance. The handle of the scissor covers a short distance, it means it moves a little bit, but the blade of the scissor covers a lot of distance. So it means that it gain in speed. It means by applying less force we can do more amount of work. These were the 4 functions of machine. Now our next topic is terms related to machine. Our next topic is terms related to machine. Terms related to machine. That what are the terms which are related to machine? The very first term related to machine is load, second term is effort, and the third term is fulcrum. These are the 3 terms which are related to machine. Let me define these terms first, then by an example I can explain you all these terms. Load. Load, we can say that the work which is to be done. The work which is to be done. The work which is to be done. That is called load. Effort, the force applied. The force which is applied on the body by the human being. Fulcrum, the pivoted point. The pivoted point is called fulcrum. Let me give you one diagrammatic example so that it will be more clear to you. Suppose this is a stone. Suppose this is a stone and a person is unable to lift and move this stone. Now what he does, he has taken a machine and he tries, this is a lever, and he tries to lift this load or to move this load from here to here. Now what he will do, he will take a big iron rod and by fixing it at a point he can move this stone from one position to another position. So this here work is to be done. Here if some work will be done, then only this stone will move from this position to this position. So this will be called as load. Here the person who is applying force to move this stone, here effort will be applied. This point will be called as effort. It means that we are applying force here to move this stone, and this is the point where it is pivoted. It will be called as fulcrum. Or one more example you can see, the same scissor that I have made. Again I am making the same scissor. Suppose this is a scissor. Here scissor, it has this blade here. The blade is capable of cutting. So this will be called as load. From here we can do the work. That point will be called as load. This point where both is being fixed, this will be called as fulcrum. And here we are going to apply force. It will be a effort. These are the 3 terms which are related to machines. Now up to here we have completed in live classes, but But now we will proceed further in this video and move forward in our next topic. Our next topic is mechanical advantage. These three terms we have to memorize, and according to these three terms we are going to understand another topic, and the next topic will be mechanical advantage. Our next topic is mechanical advantage. We can define mechanical advantage as the ratio of load to effort. We can define mechanical advantage as ratio of load and effort is called mechanical advantage. There is a formula for calculating mechanical advantage, that is load by effort. Since both is a type of force, load is also a force, effort is also a force, it means that mechanical advantage we can define as mechanical advantage is the ratio of load to effort. Now, as mechanical advantage has no unit, mechanical advantage has no unit. Why it has no unit? Since it is ratio of same quantity, same type of quantity. Since this is a ratio of same type of quantity, that's why mechanical advantage don't have any unit. Now this is a fraction. Here we can calculate the value of mechanical advantage. Now there are three things which are related to mechanical advantage. Let us see those three things. There are three things which are related to mechanical advantage. First case, three cases, in which first case, which is given in your book also, you can see from your book also. First case, if effort is less than load. If effort is less than load, then mechanical advantage will be greater than 1. If effort is less than load, mechanical advantage will be greater than 1, and it will act as a force multiplier. Three terms. Just now we have studied function of machine. In that function of machine, three terms we have used. Force multiplier I have used, change in direction I have used, and gain in speed I have used. Now all these three will be working in this. If effort is less than load, then the mechanical advantage will be more than 1, and it will act as a force multiplier. It means that in this case we are applying less effort and we are able to do more work. That's why it will act as a force multiplier. The second case, if effort is equal to load. If effort and load are both, it means that as much load is there, as much work is to be done, that much effort, that much force we are applying, then mechanical advantage will be equal to 1. Then mechanical advantage will be equal to 1, and it will change the direction. The term is it will change the direction. These things are not given in your book, but I am going giving you the concept of some senior classes also, so that you will understand in a good way. Now effort and load both are equal. It means whatever amount of work we have to do, that much force we have to apply. It means no benefit of using machine. That's why mechanical advantage is equal to 1, and it will change the direction, like we are using pulley. Next is the third one is if effort is greater than load. If effort is greater than load, it means if the work is less and force we are applying more amount of force, then mechanical advantage is less than 1. Then mechanical advantage is less than 1, and it will gain in speed, like in scissor we have seen. These are the three relation of mechanical advantage with the help conditions. These are the three condition of mechanical advantage with load and effort. Fulcrum we haven't used because fulcrum is the point where both load and effort are fixed, or both load and effort are tied, you can say that. Now we will move to the next topic. Now onwards we are going to study about the various parts of or types of simple machine. Out of next topic we will study types of simple machines. The first topic we will study here is lever. Second we will study about pulley. Third we will study about wheel and axle. Fourth we will study about inclined plane. Fifth we will study about wedge, and at the last we will study about screw. These are the 6 type of machine. I am sharing you one video with this video also, an animated video, by the help of which just try to see that video and try to get some concept. When we will be again attending the live class, then I will make you all these 6 types of machines clear. Until then, you see the video, go through the videos and read the book, try to understand the book up to this topic. This one is an advance because I am testing one video, I am attaching one video with this video also. That's why I have introduced you all these 6 types of pulley.
What is a pulley? Sometimes it is not easy to lift heavy objects with only human force. This problem can be fixed with the help of a simple machine like a pulley. What is a pulley? A basic pulley comprises of a wheel on a fixed axle with a groove along the edges to guide a rope or a cable. The load is the weight of an object, and effort the amount of force required to lift or move this object. When you put 2 or more wheels together and run a rope around them, you have created a great lifting machine. As you add more pulleys, you increase your mechanical advantage and it becomes very easy to lift the same load. The trade-off is that as you increase the number of pulleys, you require a greater amount of rope to achieve the same result. Hence, by decreasing the effort needed to lift the load, you have to apply the force for a longer period of time. The wheel and axle. When we have to move a real heavy load, we have to use a great deal of force to push it. This is because of friction, which is the force resisting the motion of the object on the ground, and gravitational force that pulls the object to the ground. The wheel and axle solves this problem in a jiffy. In this simple machine, a wheel is locked to a central axle and they rotate each other when a force is applied on either one of them. When we place a heavy load on the axle and push it, the rolling of the wheels reduces the friction to a large extent. However, the frictional force does not depend on the surface area of the object. The friction depends on its mass and what material it is made of. When there is less friction, it takes less force to move something. The effort needed to overcome the resistance acting upon the axle is relatively small. We see the wheel and axle setup in many of our day-to-day activities. A longer motion at the edge of the wheel is converted to a shorter, more powerful motion at the axle. In reverse, a short powerful force at the axle will move the wheel's edge at a greater distance. What is a lever? The lever is one of the most basic forms of a machine. They help us lift loads with lesser effort. Even though this looks simple, there are so many things going on in order to lift the object easily. A lever can be described as a long rigid body with a fulcrum along its length. Load, the object you're lifting, fulcrum, point at which the lever pivots, effort, the force applied to make the object move. We use levers in so many of our day-to-day activities. They are classified into 3 categories depending on the relative position of the load, fulcrum, and force. The first class lever, where the pivot is in between the effort and the load. The second class lever, where the load is between the fulcrum and the effort. The third class lever, where the effort is between the fulcrum and the load. What is a screw? A screw is one of the most commonly used mechanical devices in the world. It is a machine that converts rotational motion into linear motion. A screw has a long and thin metal shaft with threads spiraling along its length. It also has a turning head with a groove where a screwdriver can be used to rotate it. The strength of a screw's hold depends on the width of the threads and the distance between them. The closer and wider the threads, the stronger the hold will be. However, more threads require more rotations to attach the screw, and wider threads require more force in the rotations. The mechanical advantage of the screw increases when the angle of the spiral increases. The screw has become an integral part of the mechanical age. It can be used to hold things together, lift heavy loads, drill holes on objects. What is a wedge? The wedge is the active twin of the inclined plane and one of the 6 classical simple machines. Unlike an inclined plane, which is stationary, a wedge does useful work by moving. A wedge is made up of 2 inclined planes. These planes meet and form a sharp edge. For a wedge, the effort force is applied to the vertical edge of the wedge. We often see a wedge being used for many things, like to separate portions of an object, to lift a heavy load, or to hold an object in place and avoid it from moving. The force yielded from the wedge is inversely proportional to the inclined plane. That means if the inclined angle is small, the wedge yields a larger force and may do the job faster than a wedge with a wider angle.